All right, hey everyone, my name's Rebecca Deck. Welcome to Of Course It's Exploitable. So this is kind of the tale of how I used what I find quite commonly during application security tests to steal a bunch of money, because that's what I like to do. And CORS is something that I see in almost every test that I do these days. So I'll go a little bit of background on CORS, and then we'll move into some pretty technical content. So I hope everybody's comfortable with it. I'll try to go slow and be gentle. So what do? I do application security testing. I do configuration testing. I just do a lot of cloud stuff. That's kind of been my jam over the last year. I do secure software development training for people, but I test anything anybody wants to send me. If they're writing it, I want to test it because I love finding bugs and I love stealing things. The slides and all the code for this are up on my GitHub page, and I stuck the GitHub link at the bottom in case you miss it. So it's going to be there. I put all my presentations up there, so if there's anything else that seems interesting, go ahead and grab that, and you're free to use them for yourself if you want. I've been doing application security for about 9 years now. I used to be a software developer for about 8 years. I did IR work, forensics, sysadmin work, all technical things, and I was also in the Army doing nothing having to do with computers for about 4 years. I have lots of certs. I look a lot like a North Korean general, if you look at my page. I was in the SANS Master's Program, so if anybody wants to talk about certs and stuff like that, feel free to hit me up after the presentation. Just a quick overview of what we're going to cover. So I'll do some background on REST, and then we'll get into CORS and kind of what it is. I'll talk about ways to bypass CORS, talk about CORS and how it works with a lot of the scanners that I use, mainly Burp. Then multi-step CORS exploit, so this is the thing that I use to steal the money, and some defenses that people can use for CORS. So first off, don't be afraid. Yep.
Get a slide deck afterwards?
Yeah, it's on my GitHub page. But yeah, so don't be afraid. If you don't understand what I'm saying, that is perfectly fine, right? That is kind of the intended goal. If you've never even heard of CORS, I don't expect you to understand everything I'm going to say. I just want you to get like 25% of it, and I'm good. But if you know something about CORS, hopefully you can get most of this presentation down. And if you really know something about CORS, you think you know it pretty well, maybe you'll learn like 1 or 2 things that you can take back. So first off, what is REST? So it's representational state transfer. You often see like weird HTTP methods. You know, in a normal app, you'll see get, post, that kind of thing. But you'll also see put, patch, update, delete, all these extra HTTP methods that you don't see during a lot of normal applications. It's defined by 6 factors that don't really mean anything because people write APIs they call RESTful that don't meet all the 6 requirements. You see it a lot with microservices, and that's kind of the driving factor of why I see it on almost all my assessments now, because everybody is using microservices to do software development. You also see it if someone's using like MVC frameworks to do development. Most of the time it's JSON, but it could be other formats. I don't think I've ever seen anything in YAML on that. That would be an interesting test for me. And authentication in REST is a little bit different from your normal web apps, right? In a normal web app, you usually have a cookie value, and that cookie is what tracks your session state as you move through, like your Amazon card or anything like that. Now, with REST, the idea is everything that you need to do your authentication and come up with like your roles and what you can do in the application should be stored on the client side, not on the server side, right? So that's done to try to take the load off the server. So they'll use things like JWT, JSON Web Tokens, or HMAC tokens to keep track of what you're allowed to do, and those things are signed. That way you can't modify them. Sometimes you see multiple forms. Sometimes I feel like they're accidentally strung together by software developers. So you'll see cookies used to maintain session state, plus they'll use a bare header with a JWT in it, and they'll have a bunch of custom headers in the application. So the way they do authentication really gets kind of hairy, and that becomes important when we're talking about CORS, and especially when we start getting into false positives from scanners. So what is a cross-origin request? Well, it's anything that crosses origins and is a request, right? So that's pretty cut and dry. But yeah, so the same origin policy is kind of what defines origin. So anytime something from one origin wants to talk to something in another origin, that's going to generate a cross-origin request. And a lot of times the way we do that is with XHR, so XML HTTP requests. So it's a specific type of JavaScript call that we're going to use. And things get really sticky when you start talking about what is a different origin where XHR is concerned. There's a really good blog that I saw come out in March or April. I got a link to it at the end. But they went through and found all these weird edge cases in browsers where you could bypass some of these CORS protections just with weird little things that you're setting in the browser, different content types and things like that. And spoiler alert, it's not the same based on what browsers you're using. So that's always a recipe for disaster when you're talking about coming up with findings in repeatable fashion, right? When it matters what browser somebody's using. But the general idea is one site is probably trying to make a request to another site. So it's trying to tell you as the client, go make a request to this third party. And I might do something like maybe try to get you to change your email address automatically, right? So I write a web page that uses JavaScript and makes you make that request to change your email address on somebody else's API. Maybe I want you to hit like some internal server that I don't have access to. Like these are going to be these kind of requests. And so it's pretty much just like cross-site request forgery, but because of these protections that we have in place with CORS, it's a little bit differently how you protect it. And the fact that you're moving between systems makes it a little different than like your normal CSRF that you might have been finding for the last decade. So then that kind of begs the question, well, what is CORS and how does it help us? Well, CORS is a protection that's built into your browser. It's defined in a fetch spec. And it's really great, right? Because it is super granular. So that gives you really tight control about what people are allowed to write and force you to do in your API, which is great, right? For security, we love granularity. But one of the problems with a lot of granularity is that people really screw it up quite frequently, right? So that's kind of why I see this so often, is because people make mistakes making these kind of configurations. So the general idea with CORS is I'm going to write this web page, and it's going to tell your browser, hey, send this pre-flight request, right? So go and ask this other server what you're allowed to do. The server will tell you what you're allowed to do, and then the client will make that decision, and then it goes ahead and sends its request. So here's kind of a daisies and rainbows picture of how this works, right? So the client sends that request over to the server responds nicely, then it actually sends sensitive data, like in this actual request part over there. And then the actual response comes back from the server. But the pre-flight option stuff is kind of where things really start to derail. But the headers that it uses that become really important, origin, I'll talk a lot about that later. And then access control method and headers. So method is kind of that get, put, post, patch, all those different HTTP request methods that might be sent to the server. And then access control request headers. When you look at a browser request, it's going to send a bunch of information kind of up top. And access control request header says, hey, this website's trying to make me send this kind of information off to you. Is this okay? And then the server is going to respond back with these. Access control allow origin, most important. Access control allow credentials, talk about that. Methods and headers, that's the same idea. It's saying these methods, these headers are okay for that site to send you. Access control expose headers gets pretty interesting. So access control allow headers says, hey client, you're allowed to send these headers. But access control expose headers says, that other website is allowed to read these specific headers when I send them back. So when you start looking at like authentication tokens coming back in HTTP headers, that really becomes key to what's going on. Access control max age has to do with caching, and I don't really care about it most of the time. So I was a software developer and when I was writing code, maybe I had an API, right? And I'm trying to write some code that consumes this API, and my main concern is making this code work, right? I want my application to run so I can do my thing and move on with my life, because I don't really care about any of this stuff. But I keep getting these weird CORS errors in my JavaScript debugger, right? So as a software developer, I know exactly how I solved that problem. I went to Stack Overflow. This was on April Fool's, so it was awesome. But if you start reading it, the poster is like, I set access control allow origin to star to allow anything. And then I set all these other headers. What could I possibly be doing wrong? Like, what more can I do? And someone says, wait, disable these other controls as well. This will be your savior. And of course, people are like, oh, thank you. You've helped me by disabling all my security controls, right? And it gets pretty cool because these people who are doing their development in their lower environments, you wouldn't think that this would make it up to production, but quite often it does, right? Developers have to do a lot of these changes in the code itself, not in configuration files that we easily change as things move through development and UAT and up to production environments. So that's not something that just easily changes out. So that's kind of why this tends to roll up, I think, more than other findings do. So if you're talking about bypassing CORS, the origin header, remember I said this is the most important one. So origin is going to control where all these requests come from, right? So it's saying, hey, this site, evil.local out on the internet, is trying to make me do this. Is this okay? The access control allow origin, so when the server responds back, it can either have wildcards or it can have an exact match. So it might have a wildcard like star. Wildcards like star.good.local don't work, so you can't use them. That'll cause CORS errors to show up in your application. The only other thing you can do is reply back with like the exact domain that's making the request, and that's the only way it'll be matched and allow things to continue moving. Then you have access control allow credentials, which starts to derail that wildcard stuff automatically. So access control allow credentials says, all right, this site is allowed to tell you to use authentication information. So like your cookies, your authorization headers like basic and NTLM authentication, but not things like bearer authentication. That's got to be controlled with access control allow headers instead. So, but a lot of this normal type of authentication can be controlled only with access control allow credentials. And as soon as you try to use that, it breaks that wildcard that we saw on the previous slide, so you can't use star anymore as soon as you want to send credentials. Because somebody out on the internet, when they were coming up with this spec, was like, you know what? If any site is allowed to tell you to use your credentials to do something, that's automatically going to be a cross-site request forgery. So we should disable this as a matter of convention. So that's why the entire spec says, no, 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 never ever do that. So what you end up getting is people have to write some code on the server. And on the server, they say, I'm just going to send back whatever I see. So anything that origin header is, I'm just going to send it right back to you and say that it's okay. When you start looking at like COTS software and on-prem applications, maybe where the developers didn't know the DNS names of servers before things go into production, it's really hard for them to do a good job whitelisting where this comes from. So if I'm somebody at like IBM, I don't know who is going to buy my piece of software. So I can't say in advance what origin should and shouldn't be allowed. So by default, they just parrot back those headers. And that's a problem I see in almost every piece of COTS software. Yeah.
So this header, you're sending your connections from the site you're on to the other. That's what it's saying?
Yeah.
The other way around?
So the client is going to send access control requests, headers over, and then the server is going to respond back with what's allowed. I'm going to go through it in a minute, so you probably stick a little bit better. And they can use regular expressions, right? And regular expressions save everybody from everything. except people aren't great at writing regular expressions. So the first thing I see is this dot star, which you don't even need to think about it to bypass, right? So that's just anything I send, I'm going to say it's okay. The other thing is people think, hey, here's my regular expression of good.local, thinking it's like an exact string match. So that kind of opens you up to being able to say, well, I'm going to use good A local, good.local.evil.local, but I own evil.local, so I can register whatever I want as subdomains. So that one works quite frequently. And again, people, even if you think you're doing an exact match, exact matching on domain names is not a good idea. And then you also see people who really tried their best, right? They escaped the dot, so that way you have to use good.local. They anchored it to the front, but then they don't anchor the rear end of the regular expression. And so that opens you up to this specific type of attack. So I've had to do that on assessments before, and it works quite well. Here's kind of the code that I end up seeing in like a PHP application. So what they're doing is saying, whatever this origin header is, go ahead and just write that to the origin variable, and then send this back to the client as this access control allow origin header. And then go ahead and set access control allow credentials to be true, right? I want that user to be able to authenticate to my site. So here's kind of the HTTP request for it. So this is what the pre-flight request uses. So the pre-flight request always has that options request method. So sometimes you might see get put post there. But for pre-flight, always options. Then you have like your URL. Here's all the HTTP headers that we see. We can see, hey, it wants me to do a post eventually. It wants me to send this authorization header. And here's the origin of evil.local, right? So this is the client saying, evil.local wants me to do these things. Is this okay with you if I do these things? So I think of it kind of like my kids asking me, is it okay if somebody tells me to like get in their van with no windows? And I need to be like, no, don't get in that van. But here it is. So the server responds, yes, 200, everything's okay. Allow evil.local, allow credentials, and then we also set the content type headers, allow headers for content type and authorization. So that's kind of the server response from that previous like bad snippet of PHP code. So my kind of world lived in assuming that I was going to get stuck with these pre-flight requests. But as I started reviewing the fetch spec, I noticed something really interesting, right? So they wrote something in the fetch spec where they were like, you know, this pre-flight request is kind of a pain in the butt to deal with. I don't know if it was like network bandwidth concerns. I assume that's like the fault of most bad, or the root of most bad decisions in internet specs. But they said, we'll allow you to do these simple requests, and we won't do things like send pre-flight requests to the server on these. So you get head and post, a few headers, and by content, or by convention, post is not really supposed to update the application state, right? But nobody would ever go against like developer convention. I mean, and they say, these content types, they're not that important, right? If anybody really cared about this request, they would make you use like application JSON or something like that. But that's not really the case. And so Microsoft, in their infinite wisdom, said, hey, look, we're going to strip the request header, like request headers with cookies and credentials off of these requests. They're like, you know what? Forget convention. Forget the fetch spec. We're doing it our way because we're Microsoft, right? And that worked real well in IE6. But this wasn't like IE6 time. This was like 2010. So not super recent, but still. But when you actually look at what Microsoft does in their request, there's your cookie. It didn't send any of that like special information that it was supposed to. It just will make these GET requests because it needs to, right? That's the way specs work. That's the way this application is supposed to run. But it's kind of irritating when somebody goes through their, like, spends their time writing blog posts saying what they're going to do and then they don't do it. And then the thing that I thought was most entertaining about this is the Wikipedia page for the XML HTTP request. And so they say, no one will do this, right? Simple model does not allow the request header and that cookies. So no browser should ever do this. But all browsers do it, but now it's in Wikipedia. So that's kind of why you can't really trust what you see on Wikipedia. Because it's all based on Microsoft's 2010 blog entries. So here's kind of how this looks, avoiding this pre-flight request. So here I am making a post. It puts my origin header right here, right? So it says, look, evil.local wants me to do this. Is this okay? And it says, here's my authentication token and everything going to the API. And then the API is going to just dutifully respond to that request and say, hey, yeah, here's your origin headers. You probably shouldn't do this, but I went ahead and processed the request for you anyway, which was helpful. And then the user's browser says, oh my gosh, here's all these cross-origin errors. There is a severe problem. This didn't work, but it did work, right? So I found that to be a pretty interesting way to bypass people's origin settings. So even if you set origin correctly, you can do single requests. Now these JavaScript errors do cause problems if you're trying to do multi-part requests, but not for a single request. So when you're a tester and you're trying to do this, I see a lot of issues with it, right? Most of what we do is going to be based on scanners, and the scanners are really pretty bad with this. So they rely on the origin header quite heavily. So they're going to look and they're going to try to do those things that I did with the regular expression. They'll try to say, all right, if I modify the origin header in this way, what does that do to the application? They don't look at like pre-flight requests. So I've had developers kick back my findings and they say, well, yeah, I see it on the post, but there would have been a pre-flight request and your post request never would have happened. And it's kind of irritating to me, right? But the developers have been hurt before, right? So as a software developer, I've talked to people before and they say, well, we spend 8 hours on every single finding that we get from a third-party application testing company, trying to just validate if this is even really a finding. So that makes me kind of sad because that really kind of tramps on that developer's ability to do what developers are supposed to do, which is develop code. So I try to, remain calm when people tell me that kind of stuff, like, hey, your finding's not right, it's going to be bad. Sometimes the scanners will ignore custom headers. So they'll think that, well, I can go ahead and send this request, but then they don't check the access control allow headers response to see if the request could have been generated. So they don't look at pre-flight and the following request and manage to string all these together. And that's Burp or NetSpark or any dynamic scanner really tends to have that problem. But again, that makes customers think they're wrong, that we have made a mistake on everything we do. Maybe they think that we can only send one request at a time. Sometimes it's true. Remember, if you're going to generate those JavaScript errors, yeah, you can only get one request out of that. Maybe they have GUIDs in there, and they say, well, here's this really weird random value. You have no way of getting that random value. And these might be justified things, right? And I hate making developers fix things that they don't need to fix by rating vulnerabilities too high. So whenever developers tell me that, I'm like, you know what? All right, my finding might be wrong. It does happen from time to time. So I'd love to take a look at it. Let me write a proof of concept exploit, and then I'll get back to you, and we can see if this actually works on your page in this exploit. So I had a piece of software, and that software handled some financial payments. So it made a GET request to this RESTful API and said, hey, list out all the accounts on here. Then it made a POST request. It had this prepare to update step, and that prepare to update gave me a GUID back. And that was the thing where they said, you'll never be able to get this GUID because it's super secret. And then it made a POST request to this API to update the person's direct deposit information. It reflected the origin header, so I didn't really need to do simple requests. And simple requests wouldn't have worked in this instance. I'll show you why in a minute. They just use a session cookie to handle authentication. And this was a microservice architecture on this application. So I think they had like one main UI page, and then they had like, I think 108 different microservices behind it. And then the interesting part to me was 107 of the microservices used authorization bearer headers that I didn't know, like I didn't have a good way of getting the authorization bearer header. But this one used cookies only for authentication. So I thought, well, this one of these things is not like the other, so let me go ahead and spend my time on that. And it used with credentials with the XHR request. So that was causing you as the client to send that cookie to the server. So what I came up with was this 5-step exploit. So the first thing we're going to do is do that request list of accounts. Then I'm going to read through the JSON, retrieve the account information. Then I'm going to send that prepare to edit request, get that GUID, and then I'm going to post to update direct deposit. And what I was working from here was a burp scanner finding for CORS arbitrary origin trusted. So here's kind of the proof of concept that I came up with. So at the beginning, you have this function for run the XHR request. Doesn't really matter what the name is. In this case, I stored it in a session variable as I was kind of working with this, but you don't need to. Then you just call the first thing, list accounts, right? So that was the first thing in our 5-step process. Define the URL. Say, hey, we want to make an XML HTTP request. When you're doing this, it looks a little weird because you have to write, this is what happens after I run this request. And this is actually building the request down here. But that's how JavaScript works, so that's what I do. So we tell it here, we want to run a GET request. They had a custom header, so I just called it derpy custom header. And they had a random value, but it didn't really matter. So this was kind of that thing that protected them, right? And it was just kind of a mistake, or, well, not really a mistake. It was just like a matter of happy circumstance that prevented me from doing things like multi-step CORS or the simple requests here, because they had this custom header. And as soon as you include a custom header, that's one of those things that takes you out of that simple request territory and forces you to make the pre-flight request. With credentials is true. And then just set a response type of text. Didn't really matter. Send the request. When it comes in here, I'm just saying if I get a 200 response code, make an array, parse this JSON response that server is going to send into an array, and then step through this array and get this personnel number out of here and run this next function called getPrereq. So those were kind of our first 2 steps from our 5-step exploit. And now we're going to do the next 2 in the prereq step. So we come down here and build our request. And we say, hey, we want to use this personnel num variable that we passed in from the previous function. Set our content type. In this case, it mattered that the content type was application JSON for this. And again, that will also force you out of that simple request territory. And then we set our custom header, send our request. Things come back. We parse that JSON again. So this is where we parse out that GUID, make an array of these, and then we're going to call this update billing function. And so that is going to run on everything that is in, so that's going to run on everything that comes back in that request, or in the server response. And then we're going to go through, build our update billing. So here we make the direct deposit information and this sensitive GUID. And then we're going to make a post, application JSON. In this case, we didn't need the custom header. And send that off. And then the server is going to process that. So if you look here down at the bottom, let me see if I can possibly make this any bigger. This could go wrong. UI scaling gets pretty rough sometimes. So as we come over here, You load this first, we simulate like the user logging into the application. So this is the user running their authenticate steps down here. And then we have our own server called evil.local out on the internet. And so this is where we're hosting our malicious HTML page. And so as this runs, it's going to go through a bunch of steps. It has the options request. Maybe this would be easier in the slide deck. But yeah, so it's going to run through a bunch of requests. So it's going to run through the options. So all those pre-flight requests, going to run through the get request to list accounts, more pre-flight requests, post requests. All that might be easier seen in PowerPoint. So here we can see just the HTTP requests and responses. So you see they load up my evil page, badpage.html. Then that hits that xhr.javascript to load up my JavaScript. Then it runs through listing the accounts with pre-flight, listing the accounts with get. Then it makes the pre-flight for the prereq. And then it makes 2 requests to the actual request of the pre-flight, prereq to the sensitive operation. And then it runs the post request, pre-flight, and post request. And so in the application itself, the idea was an administrator who has access to everybody's payroll information. While they're doing their job as a payroll administrator, you host a website out on the internet that maybe has a malicious piece of JavaScript running on it through an ad. Maybe it's like a sinkhole or watering hole attack or something like that that's going to target these specific types of users. And then this will jump through and update everybody's direct deposit information over to me. Payroll goes out. I get all the payroll data or all the payroll money. And then I start transferring that payroll money away and it's gone. You're probably never going to see it again. So that's kind of the attack. When you look at defenses for CORS, I see a lot of people in AWS like fixing this on load balancers, and that seems to work pretty well for people. You have your intentional defenses. So if people use the origin header to limit these requests as much as possible. So you want to say, I only want you to allow this from these specific origins. Maybe have a whitelist that says, all right, these specific sites, if you were running like a SaaS service and you wanted to have an open API that people were allowed to call, a thing you might want to do is say, all right, who are my valid customers? That's in a database table. What domains are they using? And then only allow their specific domains. And again, you can use regular expressions in there, read that into the code, and do it that way, instead of having these kind of things hard-coded or just leaving it, reflecting it to everybody. Nonce tokens and double submit cookies are another thing that I've seen used pretty well. So that's going to be like random values that are going to be attached to requests. When you start seeing nonce tokens, those kind of move into like the normal CSRF prevention, but they do work for this as well. And again, the OWASP page on cross-site request forgery goes into a lot of detail on these things, so that's probably a good way. But really, you should focus on making sure your origin is limited as much as you possibly can, because that's your first line of defense. Using good things like the bearer headers are really helpful, because that's going to force you out of that simple request territory real fast. I've seen people use accidental defenses of those custom headers, right? So just by including any random value in a header, it automatically means I can't make you make a simple request to that. So that's pretty helpful. The authorization headers. I talked to James Kettle because this was something that came up quite often. So he wrote the burp page when Portswigger first did a blog on CORS a couple of years ago. He was the one who wrote it. And I started seeing these sites that were using bearer authentication tokens. So these JWTs and authorization bearer headers. And that was how they were tracking things, because again, that's supposed to be how RESTful APIs work. And I saw it come up on like the SANS advisory board, a couple other, like the GPON list and a couple other ones 3 or 4 times. And they're saying, are authorization headers sufficient to protect you from this? And we came up with these 6 reasons, 6 situations where they may not be. So first, any site that has access to that token can't have any cross-site scripting in it. So if you are running a SaaS service and you have it whitelisted to specific origins, any of those origins having a cross-site scripting vulnerability in them is kind of going to be all bets off. And that's true of any CSRF protection at all, right? So they'll be able to force you to make any request because now it's coming from a valid origin. The token can't be anything predictable, so nobody can just guess it. I can't make my own token for my account and then reuse it for you. You can't have a bunch of old tokens laying around that somebody could steal. The system actually has to validate the token, which sounds kind of stupid, but you do see that, right? And that's another issue with a lot of the scanners, is they'll see that there's a token there, and they never really check to see what happens if you modify that token, just that it's actually like getting sent. I can't generate tokens for your user account. So like if I'm logging in and I have kind of a, I guess, insecure direct object reference type of thing, where I make a post request to like this generate token service, but I provide your user ID, then I could get a token that's valid for you. That could still kind of shank this. Apps cannot put that token in an insecure place. So as soon as you put that token in a URL, then it can potentially be compromised. That one I think is less of a serious issue, because you kind of need to have already achieved like a man-in-the-middle position to get that token in that manner, or you have to like own their proxy, things like that. And so that can kind of be a problem. So yeah, authorization headers can be pretty helpful in that. So CORS, it secures your XHR requests. It's kind of a fundamental protection. It's part of like the whole same origin policy thing that we're doing. The origin header is by far the most important. So when you're looking at these systems, usually focus on that. Software developers need to make sure that they're planning for this if you're like systems architects and things like that. As applications come up, make sure that you're validating this origin. It's pretty easy to do with standard like integration tests can test this kind of thing. Try attacking with simple requests if you're an application tester. Just see what happens when you start seeing somebody not using headers, using cookies for authentication on their RESTful APIs. Make sure to try what happens if I just don't send a pre-flight request and send this over. Multi-step attacks are possible. So that's one of the things that developers tend to think, nobody's going to sit there and write JavaScript for my application. But it's really not as bad as you think. A lot of the times you can just steal their JavaScript and just stick it on your server, and it does exactly what you want. So that's not really a good defense, because bad people can program too. So some of the resources that I used. So Portswigger, they have a really good article on CORS. So that was like James Kettle stealing information or stealing like Bitcoin. So that's one place. There's a whole bunch of good places to look. Most of my job is reading specs. When I talk about like, what's your favorite hacker movie? I tell people my favorite one is War Games, because he spends half the movie in the library reading things. And I'm like, that's pretty much my job, is to sit there and read all these weird things and find edge cases. But yeah, so the Mozilla has a good CORS W3C. When you're looking at protections, OWASP CSRF is probably the best place to look. It has a really great article on CSRF and then a specific section on CORS. So that's another good place to go. The fetch spec, again, because I like specs. All my XHR code. So kind of my goal with this JavaScript code is that people can take my JavaScript code and run my JavaScript code in their attacks. Again, it's not going to work with that exact same thing, but you can take those general ideas, because building the request is not that complicated. And all you have to do is kind of chain them together into a piece of code and then stick it out there. And that usually settles debates really quick when you can produce proof of concepts. And so my goal is to get more application testers to generate proof of concepts on these kinds of things. And that way, that can increase confidence with developers, and I don't have to sit here and explain this to people ever again. So the CORS exploitation framework, Tim Tomes, Landmaster 53, he started writing an exploitation framework built around CORS. He gave a couple of presentations on it already, but I didn't see him post the code. He said he's going to post the code sometime in the near future when I talk to him, but just not yet. So be on the lookout for that, and maybe that will kind of lower the bar on getting people to write CORS exploits, which is going to be good and bad, I suppose. And then this same origin policy research from ORSEC. So that was that really detailed information on CORS and making simple requests by doing things like, if you set this specific kind of header, this browser will make it a simple request, and that's okay with them, even though it's not in the spec. So all these interesting edge cases, because that's kind of what internet exploits are built around, are edge cases. So, but that's pretty much it. What questions do people have? Nothing? All right. Well, thanks everyone for coming.